Hello everyone, my name Muhammad Hazrin Mansoor, metric number B09191047 from BMMH section 1 stroke 1. Today I would like to present our mini project for torsion. First of all, I would like to define what is torsion. Torsion is the twisting of an object due to an applied torque. Torsion is expressed in either to Pascal and SI unit for Newton per square meter. Torsion is important structure action that increase member shear strength. It occurs when it is twisting, causing twist force action on the member as torque and the resulting stress as shear stress. What is the shear stress? The shear stress is the component of stress coplanar with a material cross-section, and moment is the expression involve the product of a distance and the force exerted. Okay, the first objective is to draw the free body diagram from actual structure. Second, to evaluate torsional loading from the actual structure. And the last, to predict the available force from safety of factor FOS.
Alright, my name is Muhammad Aris bin Johari. I will present about free body diagram. Okay, as you can see here, this is our project. Idealized model. We use the material is steel, which is G equals to 80 GPa. For the L1 length is equals to 0.09 meter. L2 also 0.09 meter. For the force F1 equals to 35 Newton. F2 also 35 Newton. For diameter is 0.009 meter. Okay, as you can see here this is our FPD. We use equilibrium Fx equals to 0, equilibrium Fy equals to 0, F1 minus F2 equals to 0, F1 minus 35 equals to 0, F1 equals to 35 Newton. For the moment, equilibrium M equals to 0, 35 bracket 0.09 plus close bracket plus bracket 35 times 0.09 close the bracket negative minus T equals to 0. We get T equals to 6.30 Newton meter. For calculation is shear stress T, J equals to pi over 2 C4. We get we calculate pi over 2 time bracket 4.5 times 10 negative 3 square root 4. We get 6.44 times 10 negative 10 square root 10 negative square root 10. T allows equals to TC over J. We calculate 6.30 times 4.5 times 10 square root negative 3. Divide by 6.44 times 10 square root by negative 10. We get 4.402 times 10 negative square root negative 13. For initials T1 is equal to 6.30 plus bracket 0.09 times 35 bracket, close the bracket. We get 9.45. Tmax equals to Tc over J equals to 9.45 times bracket 4.5 times 10 negative square root negative 3 close brackets times 6.44 times 0 times 10 square root negative 10. We get 6.60 times 10 square root negative 13. For angle trace, angles equals to TL over JG. We get we get 6.30 times 0.09 divided by 6.44 times 10 square root negative 10 times 80 times 10 square root 9. We get 0.0010 radian. For the theta, we get 0.0010 times 180 divided by pi, we get 0.05 degree. For the factor of safety Fs equals to T max over T allow equal to 6.60 times 10 negative square root negative 13 divided by 4.40 times 10 equals to square root negative 13. We get 1.5, which is handle is safe in this working condition. For discussion, in this equation, J denotes the second polar moment of area of the cross section. This is sometimes referred to as the second moment of inertia. Formula that we use, J equals to pi over 2 C4. Now we have equation for our shear strength, and our shear stress, all that is left to do is use Hooke's law in shear to see how they are related. And lastly, the calculation. We understand that theory of equilibrium force in rigid body for an actual project. Besides, we able to draw the free body diagram FBD for an actual project and analysis the number of resultant in an actual project. Then we also able to do equation of equilibrium EOE for each point from an actual project. Lastly, we able to learn the calculation of equation. That's all for our group. Thank you.